it is now recording. So last session, we were doing exercise 3A. It was called equivalent fractions. Let's recap what you remember. So I gave you some pictures, and I tried to explain something. This is one of the things I mentioned. Let's see if you remember why. We said that this is half of a pizza, pictorially, right? And then that's the reason why it's number 2 is because when I cut it, I get 2 pieces. 1, 2. If this says 4, it means that I've cut it 2 lines, and I've cut it into 1, 2, 3, 4. 1, 2, 3, 4 pieces. So when we look at it pictorially, we can see that half of a pizza, I've got only 1 out of the 2 pieces. Versus here, if I want to have it equivalent, we can see that how many of these quarters do I need to make it the same as half? How many do we have? How many quarters? Yes, Kyle. We've got 4 of those pieces, but to make it a half, it has to be 2. Then I asked you the mathematics behind it. I said, well, one of the things that we know that we were taught in primary school was that to get from 2 to 4, you have to multiply it by 2. But whatever you do to the bottom, you must do to the top. So that's how they taught you in primary school, right? And so we say, well, from 2 to 4, that's times 2. 1 to 2, you times it by 2. Fair call. Then you do the same thing for the next one. You say, well, 2 times what? Because we're trying to make it a half, right? So half to get a denominator of 6. Half, 2 times what gets you 6? Times it by 3. So you times it by 3, but whatever you do to the bottom, you do to the top. So that means an equivalent fraction would then be 3/6. Now you would have learned that from primary school, but the question I asked last lesson was, why is it that you can do it when you say half? Whatever you times to the bottom, you times to the top, but it doesn't work if you did 1/2 plus whatever you do on the bottom, you do to the top. Why is it that plus doesn't work, yet times is okay? What was the reasoning? So last session I explained it. I said that only times work, but why is it that you can't do plus 2, but you can do times 2 times 2? So you get 2/4. Yes, that's equivalent. But here, why is this not equivalent? So someone out there said, yeah, 2/4 is the same. And someone out there says, no, 3/4 isn't. But why? What was the reasoning in my last session? Leon.
I think it's something to do with 1 times 2 stays 2 instead of 1 plus 2 stays 2.
Beautiful. So in last lesson, I was trying to explain this concept. Why doesn't it add, but yet times is okay? The logic is this. When you do half times 1, what's half times 1?
0.
Well, it's still half, which is 0.5, right? So it means by timesing 1, have I changed the fraction, or is the fraction still the same? Still the same. The value hasn't changed. You still got half. But the thing is, 1 is a very special number. There's a lot of ways to get that number 1. You don't have to write it as half times 1. You can also write it as half times 1/1, because 1/1 is still 1. Now this is key. 1/1 as a fraction, a lot of students don't realize, but when you write 1/1, that's the same thing as saying 1 divided by 1. What's 1 divided by 1? 1. So that there is still the same as saying half times 1, so the answer is still half. True. But then, how else can I get 1? You don't have to do 1 divided by 1. You can also do 2 divided by 2, because what's 2 divided by 2? 1. So who said that I had to times it by 1 when I can actually rewrite that as 2/2? Because you told me 2/2 or 2 divided by 2 is still the same answer. And if it's still the same answer, even though when I multiply it, 1 times a 2 and 2 times a 2, you get an answer of 2/4, we know the ending result is still equivalent. The only reason why we know it's equivalent is because we know when you times by 1, it doesn't change the fraction. It looks different, but it is still the same value. Why can't you add? Because if you added 1, it changes the value. Yeah, half plus 1 is not half. Okay, that's not the same. That's why adding, subtracting doesn't work, and that's why times and divide is okay. All right, that was a theoretical component. If you got that, fantastic, because that's the reasoning, the logical part to mathematics. Otherwise, you can blindly follow what I just taught you, and that's what primary school is. So a lot of times, students who get it, they memorize the mantra, whatever you do to the bottom, you do to the top, but they have no idea why they do that. They just do it. A lot of maths work that you learn, a lot of times students memorize. That's why maths becomes magical, less so logical. That's why sometimes you memorize the wrong things. You forget how to do certain techniques. You're like, oh, I know how to do it, but I've forgotten it. The reason why you forgot is because you don't get it. You don't actually truly understand the maths. You've just memorized the steps. Yeah? It'll get you to a certain point, but at some point when you start problem solving, that's where you do mistakes. Okay? Mistakes occur because you don't know what you're doing. Mistakes occur because you're following a procedure you don't know why it works. It's like your phone. Most of us know how to use it. But if your phone has an issue with it, you don't know how to fix it. You know how to use it. You know what it is, but you don't know how to fix it if something went wrong. Problem solving means that you truly understand what it is. And that's the difference between understanding maths and just doing maths. So if you do problem solving, doing reasoning and enrichment, that's what it trains you to do. It trains you to think. Yeah? Now today's lesson, we're going to take what you've learned from exercise 3A and we're going to apply that to the next logic. Well, let's add fractions. Now, one of the things I wanted you to take away from last lesson as well is that a half is not the same as a quarter. In picture-wise, this is half of a pizza. A quarter is this small. 1/6 looks like this. This is 1/6. That's 1/6. This is 1/8. Each of the pizzas are different. So here, each piece of a pizza is different. That's going to be the key thing as to why when we ask students to add fractions, you can't do this. 1 plus 4 plus 3. What's 1 plus 4 plus 3? 8. A lot of students who memorize the technique will do this next step. 2 plus 2 plus 2 is 6. Because what they're doing is they're blindly just doing add, whatever you do to the top, you do to the bottom. But you're not understanding the logic here, because if you actually think about it pictorially, this is what it means, Elliot. This is what 1 out of 2 means. If you cut a pizza into 2 pieces, you got one of them. This is what it looks like. That's one of the half pizzas. Plus means you're counting extras. 4 out of 2 does not mean just 4 out of 2. It actually means you've got 4 of these half of a pizza. That's 1, 2, 3, 4 of them. That's what it means. 4 of those half pieces. Plus, you got 3 of those half pizzas. 1, 2, 3. So when you ask yourself, how many of these half pizzas do I have? You count them. And you say, well, it's 1 plus 4 plus 3, which is the same on the top there. Yes, it is 8. But it's not 8 out of 6 because you don't have a 6th of a pizza. It can't be 6. 6 means you've got a smaller piece. It has to be 8 of those halves. That's why if you look at it together, 8 over 2 means 8 divided by 2. What's 8 divided by 2, Bo? 4. Which makes sense because every half piece makes 1. That's 1 pizza. That's 2 pizzas. That's 3 pizzas. That's 4 pizzas. Which makes sense. So in a pictorial way, when you write a fraction, you have to realize that denominator is not just a number. It represents a size of a pizza. Or in mathematics, it's a value. It's 0.5. 0.5 is not the same as 0.25, and 0.25 is not the same as 0.33. Okay? That's why when you're adding fractions, why do they teach you and they say, make sure the denominators are the same? Why do they say that? The reason why they tell you denominators need to be the same because they're telling you you can only count pizzas that are the same shape. Just like the chairs in this room. Yes, we have, how many chairs do we have in this room? I don't know. It's about 23, right? But are all the chairs the same? No. How many of those creamy chairs do we have in this classroom?
1.
There's only 1. But you wouldn't say 23 creamy chairs. Just like fractions, this could be a half. That could be a third. All the grays are thirds, and all the green ones are a quarter. You only count quarters with quarters, halves with halves, and thirds with thirds. So that's why when it comes to fractions, you can't add a creamy chair and a green chair. They're different chairs. That's why over here, why can't you add 1 plus 5, which is 6? Boys, let's not get distracted. 1 plus 5 is 6, and you can't say 2 plus 6 is 8 because they're not the same. This is a half. This is cutting a pizza into 2 pieces, and this is cutting a pizza into 6 pieces. You can't count them. They're different sizes. That's why you never had to add them. And the only way to change them to the same size is what you learnt last session, exercise 3A. There were so many ways to write half. Half, we learnt up here, half could have been written as 2 out of 4, 3 out of 6, 4 out of 8, 5 out of 10. That's why we learned to look at lowest common multiple in exercise 1C. And we said, oh yeah, well 2 and 6, yes, they're not the same. But I can change that half so that they have something that is in the same size. That's where you learned here, well, if I want it, instead of it being 2 quarters, 3 6, 4 8, and then this denominator is 6, so it'll be 2 12s, 3 18, and 4 24. That's exercise 3A. But out of them, which one has the same pieces? This is the only one. 3 6, 1 6 share the same denominator. And that's why you learn, well, what's the lowest common multiple of 2 and 6? It was 6. That's why you learned that. That's why you needed that. And that's how it applies to fractions. So here, instead of saying half plus 5 6, so therefore lowest common multiple of the denominator is 6. Fill this in, by the way, as I'm doing this, as you're listening. I hope that you picked up on the idea that each fraction is actually different. The denominator actually tells you it's a different piece. So now that you know they're different pieces, we know that they both share the 6. So right here, 6. So we need the same type of fraction. Half and 5 6 is not the same type of fraction. That's why we rewrite it. And we say, well, half was the same as 3 6. 5 6, well, it's got the same denominator already. So we can add those. Now, if you really think about it, this is not 3 plus 5 and 6 plus 6. This is telling you how many of these 6 do you have. In a pizza, if you cut it into 6 pieces, this is what it looks like. 1, 2, 3, 4, 5, 6. That's where you go buy in Domino's. They cut it up in 6 or 8s, right? So that's one of those 6. You've got 3 of them. So that means I've got this. I've got 1, 2, 3. I've got 3 of them. And I'm adding an extra 5 of these pizzas. So I'm adding another 1, 2, 3, 4, 5. And you're asking, well, how many of these 1/6 of a pizza do I have? Well, 3 plus the 5. 3 plus the 5 gives me 8 of those 6 pizzas. That's why you never add the denominators. It's not 12. You don't suddenly change a 6th of a pizza to a 12th of a pizza. Fun fact or fun story, when I was in primary school, I didn't know my fractions. I used to get money to buy lunch, and by the way, lunch was much cheaper than what it is for you guys now, but a pie for me back then, actually I can't draw a pie, but a pie was $2 for me. And I had a friend who was much better than me at maths with fractions. He came to me and I remember him asking me, can I have a piece of your pizza on one of the lunch days? And I said, yeah, sure, because I'm a nice guy. I usually am very agreeable, as you guys would know. And I didn't know my fractions, but he asked me, can I have a 1/5 of your pizza? And I got scared because when he said a 1/5, I don't know what a 1/5 is, but I know 5 sounds big. So I was like, oh, my eyes widened. And he's like, oh, okay, I can have whatever you want. Whatever you like to give me. So I said, okay, I'll give you half. And he's like, are you sure? Sure, yeah. And I'm like, yeah. And I remembered him tearing my pie in half. And I just realized how big half is. I knew what half was, but when they actually tear it in front of you and you see half of your pie gone, it really hurts. That point, I'm like, damn, how much was 1/5? How much did this guy really want if half was this much? How much is 1/5? And I was really annoyed and angry, but I didn't understand what it is. I just trusted, he took half. That's fair call. Half is easy. A lot of us know what half is and a quarter is. So I came home and I tried to figure this out. What I'm teaching you now is my understanding of what I understood after the pie incident. And it's because I realized the larger that denominator, the smaller it is, because you're cutting it in smaller pieces. So if you said 1/10, I had to cut my pie into 1/10. You get a really small piece. It's not the denominator that mattered. It was how many times you cut that piece. And that's how I learned my fractions, and I got really good at fractions and algebra from there. Yeah.
How old were you then?
I was in primary school, so that was in grade 4, going into grade 5. So it was end of grade 4. That's what I remembered. So I knew my times tables. I just didn't understand fractions. There we go. So that's a fun fact. That's how you add fractions. Now, let's do a problem together. Can you flip over to the next page? Thank you. Thank you. All right. Let's flip over. Now, these questions here have mixed fractions and improper. The first part of today, I'm only going to get you to add and subtract because I want you to get really good at adding and subtracting. Okay? Before I show you mixed fractions, I want you to practice this right now. Okay? So in your exercise book, grab your exercise book. I'm going to get you to focus on question 1 and 2. We'll do 3 right after this, but this is the first half. I want you to pick your questions, but remember, the other class, I picked a couple of students when I was checking their work. What's wrong with these students doing this? They did. This 3B. What was the problem? Students did a lot of work there. That's 1, 2, 3. That's 8 questions they did. Why was I not happy? What's wrong?
Because the harder ones are down. Right.
Why is the bottom one harder than the first one? Why do you think these students happen to only choose these questions I just highlighted? What's so special about them?
Because they're the easy ones.
And why are they easy?
Because they're single digits. No.
What is different? Let's say D and H.
Both the denominators are the same number.
That's right. They're already in the same type of fraction. That's 1/10 of each piece. That's 1/9 of each pie. That's 1/8 of each pie. So all you had to do was just add the top numbers. You just count them. These are fifths, so it's 1 plus 2, and it's 3 fifths. This one is 4 eighths. This one is 5 ninths. And they just finish 8 questions like that. But then as soon as I asked them, how do you do this one? This is what they did. They then wrote 9, 5. That tells me they truly don't understand what they were doing. Because the first bit was easy because you're understanding that's fifth. That's a fifth. You got 1 of those fifths pizzas and then you got 2 of those fifth pizzas. So together, you got 3 of them. But here, they are different types of pizzas. You have to make sure they're the same first. So to make sure they are the same, you need them to have the same. Very good. Denominator, which is the LCM. What's the LCM of 4 and 5? 20. And that's why exercise 1C from last week, or the very first week, was important because you had to know your times tables. So here, LCM, the lowest common multiple is 20. But to get 20, 4 times what to gives you 20? But whatever you do to the bottom, that's equivalent fractions. So 3/4 is the same thing as 15/20. That's exercise 3A. Here, same thing. 5 times what to get you 20? 4. So whatever you do to the bottom, you do to the top. Now you can add them. These are 20ths. Those are 20ths. You got 15 of them. You got 8 of them. Together, that's how many of those 20ths you have. You never add the denominators because you're asking what type of fraction is it? Just like the chairs, just like how you normally count, that's how numbers work as well.
When you're writing the questions in your book and stuff, do you write all of that just rather than just answer?
I do, yeah. I don't want just answer. I want question. Next step, even if you convert it or you moved on to writing 15 plus 8 on 20, then you write the answer. That's okay, but vertical layout. Okay, I need to see how you move from there to there. Okay, so that is working out as well. Yeah.
Well, yeah, I do it like you because I just sometimes I just write the question, do the working out on the question, and I then underneath.
Yep. Yeah. This is working out. That's fine. That tells me what you're thinking. Yeah. All right, team. I want you to work. I'm going to give you about 12 minutes. Pick about 8 questions. Make sure they're different questions and it challenges you. But just question 1 and 2. You got 12 minutes to work in this. I'm going to work around just to double check that you're doing addition subtraction correctly before we do question 3 with mixed fractions. All right, let's go. 12 minutes. I'm going to pause the video. All right, converting mixed fractions to improper fractions. Now, when you have 3 over 2, I want you to understand it as what does it actually mean? 3 over 2 is saying you've got 3 of those halves. Okay? So think about it. I'm going to say it again. 3 over 2 means you got 3 of those halves. So that's the half a pizza, that's half a pizza, that's half a pizza. You got 3 of them. Now when you add them together, you can clearly see that half and half makes 1 whole pizza. But then what do you have left over? You have half a pizza left over. So when we write it as a mixed fraction, we can then say 3 over 2 is the same thing as 1 whole pizza, because those 2 make 1 whole, and you have an extra half left. Usually we don't write the plus in between because we're too lazy, so we write 1 and a half. And that's called mixed fractions. Now, that's on a logical basis. That's because you can count the pieces, right? So how else would you do it mathematically? This is how you do it mathematically. So for those who don't know how to convert from improper, so write these notes, improper to mixed fraction, you literally do what it tells you in the fraction. This means 3 divided by 2. This actually means 3 divide 2. Now in term 1, you had already learnt how to do division, either by short division or long division. We know that when you say 3 divided by 2, you're asking how many 2's fit into 3. I'm going to say that again. When you say 3 over 2, students tend to mix it around. Whatever's on the bottom is you're saying how many of those bottom numbers fit into the top number. So how many 2's fit in 3? So let's calculate it now. How many 2's fit into 3? Can I please have Elliot? How many 2's fit in 3? 1. What's the remainder, Bo?
1.
Very good. So what we can see is the answer, we say it fits in 1 whole and a remainder of 1 out of what you were dividing by. Now you were dividing by halves. You're looking at half pizzas. That's why it's 1 remainder out of your half pizzas. Okay? So, to remind yourself, this is the number of wholes. This is the remainder. That's how you convert from improper to mixed. You have to do the division. Out of curiosity, how many people know how to go backwards from mixed to improper? Hands up if you know. Okay, here's an example. Let's go from mixed now to improper. What if I gave you 7 1/3? All right, Leon. What's the method? What's the trick? How do you go from mixed to improper? What do they normally tell you to do?
You multiply the whole number by the denominator.
Good. So 3 times the 7.
Then add it with the numerator.
Very good. So 3 times 7 is?
2 times 7 is 21. So 21 plus 1 is 22.
Good. So most students who've practiced this know to convert 7 1/3 as 22 on 3. But not a lot of students can tell me, why does that work? Someone taught you this. Someone said times the whole number and then add the 1. You're memorizing another technique. But why does it work? Why was it add the 2 numbers and then times the top? Kyle.
because 7 of the whole numbers is 3 over 3. There's 7 of the 3 over 3s. So the numerator is 3 times 7.
Beautiful.
And you add an extra 1.
That's exactly it. Now, for those who don't understand, that whole number is special. I want you to have a look. Here's an example just below for you to copy down. When we say 3 and 1/5, yes, the technique is 5 times the 3, and then you add 1. The answer would then give you 16 over 5. But I'm not interested in that. I'm interested in the thinking. Bo, please copy this bit. See, I'm interested in the thinking. Why is it that we do 5 times 3 and then add 1? Exactly what Kyle just said. 3 as a whole number is 3 out of 1. That's as a fraction. See, 1 whole, there's 3 of those 1 wholes. Plus 1/5. Now, we already learnt just before. I asked you, can you add these two fractions together? We know they're not the same type. These are wholes. That's 1 whole pizza. And this is a pizza you cut into 5 pieces. So, you can't add them. But to add them, we need them to have the same denominator. What's the LCMs of 1 and 5? 5. But to make 1 a 5, what do you have to times it by? 5. But whatever you do to the bottom, and can you see why it was 5 times 3? Because it's always, that's going to be a whole number, and you always need 5 of those. Because you've got 3 wholes, you're going to need to get 5 of them. So hence, 3 times the 5 on the top gets you 15. Why do you add the numerator now? It's because they're the same denominators now. It's 15 out of 5 plus 1 out of 5. So of course, 15 plus 1 over 5 gives you 16/5. But if I had to teach primary school students this, I really need the foundation to be strong. They need to understand 3 over 1, conversion 3 over 1 to 15 on 5. A lot of primary school teachers will avoid this because a lot of students would get confused. So what they do, they teach you a magical technique. They say, times that, add 1. That's why maths has always become very magical since you learn times tables. It happens at 3 and 4. If students who quit in maths, I promise you it starts around 3 and 4 to 5 and 6. Why isn't it 1 and 2? Because you guys just add and subtract. You guys can relate to that. You add lollies and you take away lollies. It makes sense to you. But as soon as you guys went to times tables, this is when maths, for some of those who actually practice, will know their times tables and they learn it well and they memorize well. Or you never learn it and you can't do division. You can't do division, you can't do fractions, you can't do fractions, you can't do decimals. You can't do decimals, you can't do percentages. This is where it locks out. From grade 4 all the way to 6, your maths life, if I had to predict, it would have started there that you started hating maths because it became magical. And that's the problem. Yeah? And so by the time you get to year 7, you would have gave up. Long multiplication, long division, would have been too hard. By the time you get to year 8, which is where I am now, that's a lot for me to teach. 4, 5, 6, 7, that's 4 years that I'm trying to catch you up to what you're missing out. And it all starts off with times tables. So if you want to get sort of okay at maths, it starts with your times tables. The better your times tables are, the better the things as I'm describing, you can follow. You can follow when I say, what's your lowest common multiple of 1 and 5? Then you can keep up. But if you can't even keep up with that, no matter how great of a teacher I am or how slow I am in teaching you this, you're never going to get it. Yeah? So that's why it starts there. So that's why I teach you the theory. I don't like to teach you just how to do. I can do that. And a lot of you who practice will be able to keep up. And those who don't, you'll never keep up. Just because it doesn't make sense. It's hard to remember. There's so many techniques to remember. But if you understand the reasoning to them, you never have to memorize. It all makes sense. See, I don't need to memorize the technique for that. I just know that because I get it. Yeah? And remember, I came from a point where in grade 4, I gave a guy half of my pie instead of a fifth of my pie. I started from there to where I am now. Yeah? So it means that you can learn. It's just how much you're willing to. All right, team. So short method we already learned. So I'm just going to write as the last bit. 3 and 1/5 equivalent to 5 times the 3. Shh. Thank you. Don't speak while I'm speaking, please. And that gives you 15 plus 1 on 5. That's how you get 16 on 5. All right? Why am I teaching you that? It's because in the next question, there's 2 ways to do this question. Can you copy this part down? 2 ways, one of which I don't like because I know you're going to get tripped up at the next exercise. Exercise 3C, we work with negative numbers. If you're going to do this question, the short method, you will get tripped up in the next one. So, this is what I want you to do. I know it's tedious. That's why students quit and not do it. But this is what I want you to do. I want you to actually convert each of these into improper fractions. So let's do it now. What's 4 1/5 as an improper fraction, Ashwin?
Is it 4 times 5 is 20?
Yep.
And 20 plus 1 is 21.
So it's 21 on 5. Very good. So this one becomes 21 on 5. Takeaway. What is 2 3/4 as an improper fraction? Can I please have Ava?
2 times 4 is 8 and then 8 plus 4 is 11.
So 11. Beautiful. This is how I want you to do it first. And then you work out, well, you can't subtract or add them because they are different fractions. They're currently different. 5 and 4ths. So you have to make them the same. So you got to figure out, what is the lowest common multiple of 5 and 4? 20. So to get 20, I have to times 5 by 4. Whatever you do to the bottom, you do to the top. Same thing with this one, times 5 times 5. So this gives you a new equivalent fraction. 21 times 4 is what? 84. Very good. Take away 5 times 11, which is 55, over 20. Now they have the same denominators. You can then add and subtract. You don't subtract the denominator because these are 20ths. I've got 84 of these 20ths, and I'm minusing 55 of these 20ths. So what's 84? Take away 55. 29, very good. All right, now, some of you are looking at it like that, and you're thinking, wow, those numbers are huge, and then you might have given up. That's okay, just learn the process, yeah? What's the short method? Here's a short method that students may have learned from primary school. 4 1/5, take away 2 3/4. What some students do is they take the whole numbers. 4 take away 2, it's 2. And then they say, let's just work out 1/5 take away 3/4. So they do 1/5 take away 3/4. Let's work that out. Same thing, lowest common multiple is 20. So I need in 20s. If I times the bottom by 4, I have to times the top by 4. So this gives me now 4. I have to times this by 5 to make it 20. So I times the top by 5. That gives me 15. 4 take away 15. Yeah, and this is where the mistake comes in. 4 take away 15, unless you're still okay with integers from chapter 1, from what we did last term, you might make a mistake here. What's 4 take away 15? So it's negative 11 over 20. This is what students get confused when they write their answer. They say 4 take away 2 is 2, and then minus 11 over 20, and they're like, is that the answer? And they get confused on what to do. You see, I made this question specifically so that it doesn't work easily for you. I'll show you what the textbook is, and you can use this short method so much easier. This is why I don't like the textbook, because they give you this false sense of security. So if you were to answer this question, let's do their short method. Whole number with whole number, 7 plus 2 is 9. Notice this is already in fifths. So if you added 2 fifths plus 1 fifth, how many fifths do you have? If you check your answer in the back, that is correct. And that's what students do. You guys can go through all these questions here, even the subtraction one, if you did the same thing. 3 take away 1 is 2. 5 eighths take away 2 eighths gives you. Can you see why I don't like this method? Because you can do it this way, but as soon as I gave you my one, even though it's still a fraction, students will give up. Students will look at this and say, I don't know how to do that bit there. That's why I don't want you to just go 4 take away 2 and then 1/5. If you did know your fractions well, you can take the next step. 2 take away 11 over 20, you would have to do this way. Make the denominators the same. So times this by 20, times this by 20. And you should get 40 on 20, take away 11 on 20. What's 40 take away 11? Same answer as the one I gave you. I know this feels long compared to the short method in your textbook, but if you rely on your short method, eventually it's gonna bite you. That's what I meant by if you memorize the technique, but you don't know why you're doing it, you get stumped here. This is the problem right here. So often when I teach maths, I try to get you to avoid making the mistakes that I see all the way up to year 12s. It's because you guys learn all these shortcuts. And some of you are really good at it, but you don't truly get the reasoning. So I teach you the basics. I know it's long, but I want you to do it because that builds up your foundation. The better your foundation, just like how I learned my fractions, the stronger your maths will become. Yeah? So this is how I want you to do it. I do want you to change to improper, then do what I've taught you for addition, subtraction. Don't do the short method until this is second nature. If your foundation's strong, you can do whatever you want. I do it this way, but I know my foundation. You need to build your foundation. Don't do the shortcut. Yeah? That's it for today's lesson. So if you do it this way, you build yourself for next lesson, which is 3C. It's going to have negative numbers and you'll get into traps or walls. You meet a wall when you can't follow through. So stick to what I'm teaching you. This is what I want you to learn. Takes longer, takes more multiplication and division, but that's how you build your basis. Okay? There's no shortcut. It's like gymming. There's no shortcut to building strength. All right. I'm going to stop the video and then I'll come around and help.